Hello students, welcome to this session where you'll learn how to perform experiment 7 in your DST lab. The seventh experiment is you have to design and realize a synchronous counter using flip-flops. So counters, there are different applications. I have just shown you here a currency note counter. So which counts the number of notes that are put into the machine. So this is just one application which I am showing. Like that, there are so many applications where you need a counter which needs to increment at certain instance of time. So now our objective is we will realize a 4-bit synchronous counter using JK flip-flops. So in order to do this, you need to have an understanding of the operation of flip-flops, what is toggling, what is clock signal, and what type of triggerings are there for your flip-flop, and what is the difference between synchronous and asynchronous circuits. And the important thing is you should know the difference in designing an up counter or a down counter, whether it is a synchronous counter or an asynchronous counter. These concepts should be known before you attempt doing this particular lab experiment. So I have provided here certain reference points with respect to synchronous counters, what a synchronous counter can do or cannot do, and how it needs to be designed, what types of triggerings you can use for this, and how it can be designed using which type of flip-flops. So all the points are given here for your reference. Then moving on, the apparatus required for this is we are trying to develop a synchronous counter using JK flip-flops. So surely you need JK flip-flop ICs, and along with that you also need an AND gate IC, because in synchronous counters, once you see the circuit diagram, you will realize the need for an AND gate IC. And you need input switch to apply your clock signal to the counter, and output LEDs on which you will observe the counter output, and finally some protective resistors to protect your ICs and also your LEDs. And coming to the equipment, you need power supply and breadboard and some connecting wires. So this is the pin diagram of the JK flip-flop IC which you are going to use, and the AND gate IC. And this is your circuit diagram. So since we are developing a 4-bit counter, we are going to use 4 JK flip-flops here. So flip-flop A, B, C, and D. And always remember, so to the rightmost side you have your MSB, and to the leftmost side this is your LSB. And why it is called synchronous is the same clock signal is being applied to all the flip-flops simultaneously. That is why it is called a synchronous counter, because in an asynchronous counter, output of first flip-flop will be given as input clock signal to the next flip-flop. Whereas here, the same clock signal is being connected to all the flip-flops. So that is why it is called a synchronous counter. So please follow the procedure which is given here. Place the required ICs, make the power supply and ground connections and all the connections according to the circuit diagram which is shown here. And once you do that without any loose contacts, when you apply the clock signal, you should be able to see an increment in the count on the LEDs which are in your circuit. So this is the experimental setup, and I have highlighted all the equipment which we are using. So this is for your reference. So what are all the safety resistors, the input dip switch to apply clock signal and all such things. And now you have to verify this particular truth table. So counter means it needs to count, increment. So for the first clock pulse, before you apply anything, the count is 0. Then when you apply a clock pulse, the count is 1. Then when you apply next clock pulse, it should be 2. So in this manner, the count goes on increasing in this particular order. So the count keeps increasing till you get your 1111 at your output, and later on once again the count comes back to 0. The counter is reset. So this is what you have to verify there. Now let us see how we perform this particular experiment using Tinkercad. So now this is the experimental setup which I have already shown you. Now here through the dip switch, I am going to apply clock to my circuit here, to all the flip-flops here. Now let me start the simulation. So initially if you observe, the outputs across the LEDs are zeros. Now when I am applying clock, your clock should be having edges. That means either a 0 to 1 or a 1 to 0 transition. So now how do I apply clock is, I will switch on this and I will again switch it off so that it will generate a negative edge. So now I am switching it on and again switching it off. Now if you observe the output, the first LED has glown because it has observed one clock pulse at its input. Now please keep looking at the LEDs. I will switch on and off the clock. So for the next clock pulse, it is 2, 3, 4, 5, 6, 7. So like this, I am applying clocks and you can see the increment and increment in the count for each and every clock pulse. So once it reaches 1111, then again when I apply a clock pulse, the counter is reset to 0. So this is how you need to perform your experiment. Please make the necessary connections and perform your experiment according to what is required. So what is the result that we have observed from this? You have basically designed a 4-bit synchronous counter using JK flip-flops and you have verified its functionality by verifying the truth table. Now, once you have done this, the assignment for you is, you need to design a 2-bit synchronous counter using D flip-flops. So this is the assignment which you need to do on your own using the knowledge what you have gained from this particular session. And these are some Viva questions which will be helpful to you further for your GATE exams and also for your placements. Thank you, students, for attending this session. I hope this session is useful for you.